Homogeneous linear differential equations with constant coefficients. Case number 2, repeating roots. So the roots are repeating. We have, for example, m1 is equal to m2 is equal to m3, and so on. Then the general solution of the homogeneous linear differential equation with constant coefficient will be y equals c1 times e to the mx. So we don't have a subscript for m now because the roots are equal, so we'll just use m. So we have c1 e to the mx plus c subscript 2 x e to the mx plus c sub 3. So this should be c sub 3 times x squared times e to the mx, and so on. Okay, example, solve the differential equation d to the fourth plus 6d cubed plus 9d squared acting on y equals 0. First, we write the auxiliary equation. That's m to the fourth plus 6m cubed plus 9m squared equals 0. And then from this, we can factor out m squared, which is common to all the three terms. We factor out m squared, and then we're left with m squared plus 6m plus 9 equals 0. Next, we factor m squared plus 6m plus 9, and we have m plus 3 times m plus 3 equals 0. So the roots are 0 and another 0 for m squared. And then we have negative 3 and another negative 3 for the m plus 3 factor. And now the general solution would be y equals c1 e to the 0. Then for the next solution, we will start to multiply x. We will have c sub 2 x times e to the 0. For negative 3, we have c3 e to the minus 3x. And then multiply by x again, we have plus c sub 4 times x times e to the negative 3x. E to the 0 equals 1. So the final solution is y equals c sub 1 plus c sub 2x plus c sub 3 e to the negative 3x plus c sub 4 times x times e to the negative 3x. Example number 2, solve the differential equation d cubed plus 3d squared plus 3d plus 1 acting on y equals 0. So we write the auxiliary equation first. We have m cubed plus 3m squared plus 3m plus 1 equals 0. We will use synthetic division here. We write first the coefficients of m cubed, m squared, m, and the constant term 1. So we have 1, 3, 3, and 1. We can try 1 or negative 1. Okay, let's try negative 1. So if we bring down 1 times negative 1, we have negative 1 plus 3 should be 2 times negative 1 is negative 2 plus 3 is 1. 1 times negative 1 is negative 1 plus 1 is 0. We now have the factors of the auxiliary equation. We have m plus 1, that is from this root, times m squared plus 2m plus 1. So these are the coefficients. Coefficient of m squared, 2m plus the constant term 1 equals 0. Okay, then we can factor m squared plus 2m plus 1, and that is m plus 1 times m plus 1 equals 0. So we now have 3 repeating roots. That's negative 1, and another negative 1. Then our general solution will be y equals c sub 1 times e to the negative x plus c sub 2 times x times e to the negative x plus c sub 3 times x squared times e to the negative x. Example number 3, d to the fourth minus 5d squared minus 6d minus 2 of y is equal to 0. So the auxiliary equation is m to the fourth minus 5m squared minus 6m minus 2 equals 0. Okay, so we'll use synthetic division here. First, we write the coefficients. 1, 0 for m cubed, then negative 5 for m squared, negative 6 for m, and the constant term, negative 2. Okay, let's try negative 1. So bring down 1 times negative 1 will give you negative 1 plus 0 is negative 1 times negative 1 is positive 1 plus negative 5 is negative 4 times negative 1 is positive 4 plus negative 6 is negative 2 times negative 1 is positive 2 plus negative 2 is 0. We have one root now, that's negative 1. So if this is m to the fourth or fourth degree, this is the third degree, so we'll still need to continue. Let's try again negative 1. Bring down 1 times negative 1 is negative 1 plus negative 1 is negative 2 times negative 1 is positive 2 plus negative 4 is negative 2 times negative 1. Positive 2 plus negative 2 is 0. So this is now second degree. 1 here is the coefficient of m squared. So we can stop here and we can try factoring that binomial. So these are the factors. M plus 1 times m plus 1 times m squared minus 2m minus 2 equals 0. Okay, so let's try factoring. So the only factors for m is m times m, and the only factor for 2 is 1 times 2. Can we get a negative 2 in the middle? No. If we say 2 here is negative, that means one of the factors should be negative, factors of 2. And then if the middle term is negative, that means the bigger product should be negative. So the bigger product is 2 times m. So this one should be positive. But what we get is negative m, not negative 2. Okay. So that means we cannot use factoring here. Instead, we will try the quadratic equation. That's minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so we plug in the coefficients. We have negative 2 for b, this one here. And then 1 for a, this one here. And negative 2 for c, this one. So we have 2 plus and minus the square root of 2 square is 4. And then negative 4 times 1 times negative 2 is positive 8. So we have 4 plus 8 all over 2. 4 plus 8 is 12. We have a square root of 12. And 12 can be factored as 4 times 3. We do that because we can extract the square root of 4. And we have 2 plus and minus 2 times the square root of 3 over 2. Divide by 2, we get 1 plus and minus square root of 3. So the roots are from here and here we have negative 1 and negative 1. From here we have 1 plus square root of negative 3 and 1 minus square root of negative 3. So these are the only repeating roots. These two roots are not repeating. These two roots are distinct. So the general solution is y equals c sub 1 times e to the negative x plus c sub 2 times x times e to the negative x, and then c sub 3 times e to the 1 plus square root of 3x plus the last term c sub 4 times e to the 1 minus square root of 3 times x.